All right. Hi, everyone. Thanks for joining us today. We're going to go ahead and get started. My name is Mike Klein. I'm a director with Liberty Mutual's Big Data and Analytics Group. And Yi Ching.
My name is Yi Ching Wang. I'm an IT architect for Liberty Mutual Insurance, work for Mike's department.
We're here today to talk to you about our Hadoop journey, kind of what we've done with Hadoop on premise. And our fancy tagline, right, is one small Hadoop footprint, but one giant leap to understanding. And hopefully you'll see through this presentation what we mean by that. I'm going to start, we have some North Stars in the group, some things that we're striving for. And these are, you look at these, they're not necessarily technical, but they're critically important. We're trying to empower Liberty Mutual to leverage the vast data and talent. Talent's a huge part. We have many, many smart people and buckets of data, but it's connecting those two things together in a way that is meaningful. We're trying to make analytics easy. You'll see later on in the slide, right? Analytics is not easy. It's not something that's super simple. It's getting better each day, but it is still difficult. And we want data to be free and secure, right? Oftentimes, you kind of see this dichotomy. It's like everybody wants the data to be everywhere, but it also has to be secure, and there's like this tension between the two. So we'll talk a little bit about that. We're trying to foster a culture of quick experimentation, essentially the agile practices, right? So encouraging people to experiment and fail, and then pick up from that failure and try again. And then, for all intents and purposes, we're trying to erase the line between business and IT. Right, so you'll hear me talk about that. You'll hear me talk about the business and IT. I'm doing it really just for a frame of reference, but really we're trying to erase that. Our CIO has a tagline that he says, "Hey, we happen to be an IT company that sells insurance, rather than an insurance company that has IT." Right. So just a little bit about Liberty Mutual, where last week we were ranked the 75th company out of the Fortune 100. We have over $37 billion of revenue on an annual basis. We have about 55,000 employees in the United States, more internationally, right, spread across 5 different continents. And we have about 5,000 IT professionals that help support that organization. So today we're going to kind of go through this journey about how we think about analytics, how we work as a team, what are these data scientists that everybody talks about, and how does the data lake, and then Yi Ching is going to take us how the data lake that we built on premise takes us, how it's helped us. Our data lake that we're talking about today is on premise. We are moving to the cloud. There's no doubt we're moving to the cloud, but we found that having a beachhead on premise, it really helped our organization move faster. So we'll talk about that. All right, when we talk about analytics, I thought it might be useful just to define what we mean by analytics, because a lot of times people just say those words and don't really, it means different things to different people. So when we talk about analytics with our business partners, we talk about getting the data, landing the data, and then studying the data. So getting the data, from all the different sources that are out there, which are numerous and growing. Landing the data, and by the way, this is true for big data and other types of data, right? So landing the data, be it in SQL, Oracle, Teradata, you name it, and then studying the data. Typically we use SAS in the previous years. Now we're moving more and more towards R and Spark and Python and those type of languages and libraries. The last little bit that isn't on here is get, land, study, and then share, right? So at the end, once you have these insights, you need to be able to communicate them effectively to your business partners and to the business as a whole through either a BI tool or ArcShiny or numerous different ways. So what about the data scientists? So, and you guys probably have seen this slide or something similar to it, right? A data scientist, or a true data scientist by definitions from years past, is a PhD credentialed person that has business knowledge, mathematics, statistics background, and an engineering mindset, right? Extremely rare to have all 3 of those and to be really effective. What we're trying to do in our group, Yi Ching and I, we're trying to build data science teams, essentially, right? So a group of energized engineers, and that's important, right? Not just people that are kind of interested in this stuff, really passionate about data analytics. So they're software developers, they're data engineers, they're analysts, and there are some PhD data scientists, right? But you don't have to, this is my belief, right? You don't have to be a PhD to be a data scientist, right? There's tons of value that somebody can deliver to the organization and not have that level of credentials. So when we went out and talked to our business partners, that's largely who my customer is, right? My customer are other groups inside of that large organization that we described before. We found analytics is hard, right? no surprise there, right? So many suppliers and vendors will tell you, hey, it's so much easier, just buy these tools. But the tools are still hard, and they do require some special skills and knowledge of those skills, especially in the Hadoop ecosystem, right? It is this jigsaw puzzle of things you have to put together sometimes. And it is getting better and better through the years, right? I mean, the tools are getting more and more mature, but they do require some specific skills. The security and analytics have competing goals, right? So what I mean by that, and I don't know if you guys have found this in your organization, but oftentimes security says, you can't have anything unless you explicitly tell me why you need it, right? And then you have the data analytics folks or the data scientists saying, give me everything because I'm not sure what I'm asking for yet, right? And there's this tension between the two. Like they both are kind of right, but they are at conflicting odds and they have different goals and objectives. So we have to figure out a way to break that down so this is not this constant tug of war. And we'll talk about how we did that. And then last but not least, I hit on it before, is the IT business collaboration. Like folks need to, like I said, we're trying to erase those lines. Like there are data scientists that are in IT, right? There are developers that are in the business. Like there is not this, everybody who's technical is in IT. Like those, especially in this data science realm, we do have data scientists or analysts that code, right? In R and Python and all these other types of things. And we need to figure out a way to better collaborate together and not have these rigid silos, for the lack of a better term. So where do some of these frustrations come from? Why is analytics so hard? This is kind of the classic picture, if you will. Like, you have all these source systems, on, I don't know what side it is for you, but it's on my right. And even the source system is actually even further upstream, right? This is just the relational databases that it lands in. Then they can put it into marts and warehouses. Some of the lines go all the way to the BI tools that are using it. Other times, they're aggregated together in a warehouse. There's this hard separation at the bottom there between IT and the business. Then you have these data scientists that are kind of left with, a bunch of questions. I mean, their access to the data is, if they're lucky, direct SQL query to the database, but largely it's going to be through one of these BI tools, right? And they're left with questions like, well, one, why did it take so long to get the data that I'm looking for, right? And it took so long because it's like, well, who do I talk to? What department is that in? What database is that in? All those types of questions. What did the original data look like, right? So as it goes through this, the distance from the original source system to the analyst is a long journey, and there's a lot of assumptions baked into that journey for right reasons at each stage, but at the end, it's kind of like the game of telephone, right? What comes out the other end, it's kind of like the thing that went in the beginning, but it's not exactly the same, right? So how can we, get the analyst to see that direct data, that original data source? Who do I talk to? Where do I go? I can't call the help desk and say, hey, help me get to a petabyte data source, right? I mean, I need to have connections between and we have those, right? We have those connections between the IT teams and the business partners, but they need to just be strengthened, right? And much more of a partnership together. And then is there more data that I can't see, right? So there's these things that are produced through the different BI tools, but what about all this other data? Is that everything? Or is there other data that is important to me that you might, that again, through that assumption chain, people might not understand that it is important? And what about tools that are emerging? R, Spark, H2O, all these different things that are not, not part of our legacy install base, if you will. They're things that, they are now installed at Liberty Mutual, but what if something else comes out tomorrow, which is very likely, right? Something else will come out and people want to be able to use it very quickly. How do I hook up the data scientist to that data, make the data free, and secure it with something that just came out yesterday, right? That's the challenge before us. And then, of course, what about open source? Like, a lot of these tools are, all of the examples here are packaged products that are vendor support, yet I want to use Spark. I want to use, the Hadoop ecosystem. I want to use Pig, et cetera, right? How does support work in that environment? So they're left with lots of questions, some of which they actually want answers to, and honestly, some of the questions, they just want us in IT to deal with it, right? They don't actually want to know all those answers. They want to know about the data, but they don't want to be concerned about all the other different pieces. What we're trying to evolve it into, and again, this is a journey, is what we did, and Yiqing will go into the details of it, but is we built this Hadoop data lake built on HTTP. It's small. It's more like a data puddle than anything else. It's only 8 nodes, right? So very small. But it allowed us to really crack some insights that our business didn't know before. So we took the data from the source systems and we dropped it on the lake. Now, some might ask, doesn't that create a copy of the data in 2 different places? It does. Is it ideal? No. But is it good enough to get started and to make those data scientists happier and to eliminate the cost of delay of trying to figure out, what is the right solution, the perfect solution? So we also took unstructured data and data sources that were non-traditional in the past, right, and started dumping them onto the lake, leveraging Spark and Hadoop. You'll notice that the arrows kind of turn around in that study phase. So now it's Python, R, SAS, H2O, et cetera, now interrogating that same data source from many different tools, right? And if something does come out tomorrow, in a secure fashion, we should be able to spin up another engine and just interrogate that data. At the bottom, you notice that wall's gone. So removing that wall between business and IT, especially as you go more and more from one side to the other. And the data scientists can iterate and learn, and they are getting comfortable with failure as well, right? Recognizing that it's an iterative process. Nothing's going to be perfect in the beginning. They're getting more and more familiar with the software development lifecycle, right? Checking in models as code. Like, those are not things that they were used to. Those are things that IT is bringing to them, and they're growing from that. Excuse me. So what we did is we formed one team. So what this is a mix of data scientists, like business side data scientists, with IT data scientists, engineers, and developers. So we got together and we said, okay, let's tackle a problem, be it text analytics, be it streaming analytics, predictive analytics, you pick it. And let's get together as one team, like really no barriers between the two, and tackle the problem. So we formed one squad, is what we called it. We operate in an agile fashion, and we just tackle the problem, and we just work it until we get to the end of the sprint, and then we figure out, how do we do? Did we make some progress on this? Yes or no? I think the key message here is that it is really one team, right? So if there's this question of, oh, who do I talk, if the data scientist on the business side says, hey, is this all the data? Either our folks directly can answer that, or they know exactly who to go to talk to, right? There's not these long lines of chains of communication that have to happen. We found that even though there's a lot of data science happening in IT, and there's a lot of IT, as I mentioned, happening in the business, right? So having those two groups together, they're able to learn quickly from each other. So now Yiqing is going to start to talk a little bit about some of the different experiences that we had on the lake. A key message through his whole presentation is kind of, recognize that this is the same lake. And again, Liberty Mutual is a large organization. We have different lakes for different business units and whatnot. But the lake that we're describing here, we're all used on the same 8 nodes, right? Which is important because it's a lot of value out of a small unit.
Thank you, Mike.
Yep.
So I'm going to talk about how we build the data lake and our use case in the data lake. In our data lake, we have 2 clusters, one for production, one for test environment. Each cluster has 3 master nodes and 5 data nodes. Each data node has a 256 gigabyte memory and 20 core CPU, 24 gigabyte local hard disk drive. So the total space is 120 terabytes data. Even this is we can handle hundreds terabytes data from big data perspective. This is still considered a small cluster. From software perspective, we installed most of Hortonworks ecosystem components. The circle we put here has top use cases. From end user perspective, they use Zeppelin and Embarrass views to connect to a server, run the ad hoc query or data science programming using R or Python. Data loading with Scoop utilize a lot of peak hive MapReduce Spark, you have a heavy-duty Spark workload. We use Spark to run not only machine learning, we also utilize Spark SQL to do the ETL style work. So we can ingest the data, load data in the HDFS, and use Spark SQL to do the transformation. Security perspective, we have a Ranger for the data authorization. We have Knox for the perimeter security, and HDFS data encryption. From enterprise perspective, the most painful thing is security. So everybody know how hard is security, right? So in the big data environment, we must build highly secured and multi-tenancy data lake cluster. Without proper security implementation, even we have a lot of fancy functions and functionalities, we couldn't even use a data lake. So nobody want to use without security enabled. When we talk about security, we always talk about big three things, which is data encryption, user authentication, and the data authorization. We have a centralized AD server. So user will have the AD credential created in the AD. And we have a different AD group for each project. In the data lake, we have a different edge node. We can host an Ambari server running Spark, Chauffeur server, and running Zeppelin through the Linux server. All these applications, we enable the Kerberos authentication, use AD, and key distribution, use AD server as a key Kerberos distribution center. In the data lake, we have because the data lake is not only for one project, one application, we have a lot of sensitive data over there. For example, we have a legal application, we have a HR, we have finance application. Each application group, they don't want to access the other people's data. We enable the security zone in the HDFS, so data stored in the Hadoop data lake must be encrypted. From application level, we have a Ranger policy plugging to the Hive HDFS, protect the data from the application level, right? So, but we not only stop right here. If a user use command line SSH log into a system, they can skip the Ranger policy. So from OS perspective, we have to put HDF ACL to protect data. We use Scoop to load the data from different kinds of database to data lake. Yeah, the Scoop security depends on the different data sources we are working on. We can enable Kerberos. We can put an SSL in the connection string or put the encryption you could choose on the different databases. We have different alternatives working over there. Once we build the environment up running, so we must allow people to access easily. So we can run into different kind of challenges, and the user want to use BI analytical tool to access a data lake, to do ad hoc query. And they also want to integrate the different software tools or to store the data, historical data in the environment, and do the data streaming. So once we build security correctly, everything looks like should be easy. But actually, before security implementation, everything works fine. After we enable security, everything breaks to pieces, right? So you know that. So we have to reconfigure the Kerberos configuration, for example. For the different component plug-in, we have to enable Kerberos. Security not working just one thing. They all work together. So we have to use combined security mechanism. For example, we are talking about ranger policy is not enough. We have to use HDF ACL to protect the raw data. Also, when we hook in the BI client tools, we deal with different kind of BI software, like Microsoft BI, Power BI, and Tableau, Cognos, or data virtualization tool, like a DB visualizer. So different tools have a different connection mechanism. So because our data lake is Kerberos enabled, not every tool support Kerberos. Like Tableau, they support the Hive Kerberos integration, but they don't have a built-in driver for Spark. Power BI, they don't have a Spark authentication, but they give you the generic ODBC driver you can install in your local client-side environment to enable Kerberos. So it depends on which tool you use. You have to figure out what's alternative. We use a lot on Spark. We use a lot of Spark, for example, machine learning, that kind of functionality. Spark security, actually Spark has no security at all. And because we enable Kerberos, we use Kerberos for authentication. When we run the Spark surface server, the client uses Kerberos ticket sign authenticate to the Spark surface server. To protect the data, we have an AD group provisioned in our data lake. So we can choose which AD group we want. When we configure environment, we have a lot of AD groups. For each project, we set up AD group so we can provision in the data lake server. User can use the same enterprise credential log into the environment. In the recent release, Hortonworks has a LLAP bundled with Hive and Spark. They just come out like HTTP 2.6 has announced of Hive LLAP integration, which is GA. 2.61, 2.62 is going to have Spark LLAP enabled. So not just only for the Kerberos, we use Kerberos authentication, we use AD group, HDF ACL, then we can still use Ranger, Spark SQL, and LLAP combined technology for the data author, for the row level security and the column level security. Once we figure out security, so other use cases should be simple. From business perspective, they want to hook in the BI tool to the data lake. This is a very typical use case. Power BI as a front-end tool, they want to access data loading the data lake. We have a lot of billing data in cloud. We have AWS, we have Azure, we use a Power BI Cloud Foundry. We integrate these billing data in the Hadoop data lake. So let's talk about like what is the old way, right? So if we want to build enterprise reporting in the old fashion, like by using relational database, the first thing the IT going to ask a business analyst, what is your data table DDL? Tell me what's your schema. Tell me what do you want to do. So give me the report requirements so we can figure out, design the table DDL for you. Then we figure out the transformation. How do we load the data? Put into the relational database. Then you can hook in, develop the enterprise reporting, hook in the BI tools to build the report. So by using Hortonworks Data Lake, we can simply just land the data in the Hadoop. So the ETL developer we put here doesn't necessarily have to be the IT developer. The business user can use whatever tools we provide to them to look at the data immediately. Then quickly figure out, oh, this is model I want to build. Then build a Hive table on top of it, do the transformation by using Spark SQL. Then doesn't like the result, just drop the external table, then create another set of a schema, do it from scratch. So this kind of iteration quickly deliver the report output to the end users. Yeah, we also not just only we quick development from performance perspective, Spark SQL is like a 10 times, I would say 10 times faster than the traditional database. Depends on how much volume you deal with, right? From the connectivity perspective, we use Spark ODBC driver. We install driver, if your user use Power BI desktop, install driver in their desktop. If we, to deploy the model, we have a Power BI gateway server. We can access the data on-prem. So Microsoft doesn't have a built-in driver for Spark on-prem. So we have to load the Hortonworks Spark driver, put into the client's server environment, and configure the kernels. That's the only limitation we have. So we could, probably next release on Power BI, they can figure out what is the right Spark driver for the data on-prem. This is another typical use case. It's happened on the same data lake. In our data lake, not only you can use existing components, you can also add in other open sources, like Elasticsearch. We have a business case, I want to load the experience data, which has an enterprise quitting score. I want to provide the business name, street address, then zip code, city, and state. The data includes historical information. The name could be changed. So the business want to do the fuzzy match, not exactly string comparison. So the traditional SQL Oracle database won't be able to do that. Even we use Spark or Hive, you have to do the table scan. Because I give you an address, tell me what's all the 500 attributes in that data set. And also this is a fuzzy match. You have to scan the entire database, right? So to solve the problem, we utilize Spark and Elasticsearch combination. Elasticsearch has a Hadoop plugin. You can hook into the Spark, and then you write a very simple Spark Scala code to write the data, read the data from HDFS, and write into the Elasticsearch. You see this little box on the right here. It's just the Spark submit command line. It's running master mode, young mode, running a 4 executor. Each executor take a 1 GB memory and read Experian data. Experian send us about 100 GB data every quarter. So include a couple years historical data, the entire data size could be terabytes. So scan the terabytes, what is the performance we want to pursue? So SQL Server, Oracle database, to the table scan, fuzzy match. Couple minutes, probably the best, right? So if you would take a look, so the code to write Spark read data right to in the Elasticsearch is just extremely simple. 3 lines code actually. Read the data, then combine the data together, then save it to the Elasticsearch. So any developer can do that. So
this is using it's doing the ETL.
ETL, yeah, it's just to save it to the Elasticsearch. Use Spark. Spark is so fast. Depends on how many nodes you install in Elasticsearch. We have to slow down Spark a little bit in order to write the data. If Elasticsearch otherwise couldn't handle this. Once the data write into the Elasticsearch, we can run this kind of REST API call to do the fuzzy match. the performance against the 100 gigabyte data is a sub-second, which I'm totally surprised. And you see how simple this solution is. You have a terabyte data, is loaded into the data lake. Then you use 3-line Scala code, right to Elasticsearch. Then you can write your REST API to do the fuzzy match right here. So like city, fuzzy match, name equal eChain, then you're going to reply the 500 columns of the entire data sets. The performance is in sub-second. So this is a little bit of magic. I like them very much. Another use case we have here is for data archiving. Why we build this data lake? This data lake is to store the data. We have a machine logs. We have a SharePoint log, different logs, syslog server. We turn on the Apache Flume. We can stream the data into the Hadoop, right to SDFS. Also, we can use Hortonworks data flow, which is all NiFi, to build the UI-based workflow process. We have a Spark. We have a Splunk running using by existing environment, which is doing like a real-time security metric monitoring for the hot data. For like tons of security log, warm data, we save in HDFS. Hadoop data lake can have an API talk to Splunk. Splunk can pull the data, running MapReduce, get it to another kind of analytical analysis. I like use NiFi to build the workflow because it gives you like a one-stop shop. You have a centralized UI environment. You have provide different multiple interfaces. In this example, we have a SharePoint log right to the Kafka streaming. Then NiFi read from Kafka, then merge the log file to the big log file. Depends on, we want like every log file, we don't want a miscellaneous log file right to the HDFS. We want to set up the threshold when the log file size hits 1 gigabyte right to the HDFS. So you see this is a sample data flow diagram. Different Kafka string as an input data source, then merge content, then hitting to the 1 gigabyte data file size, run right to HDFS. It's a very simple use case. Once we build a data lake environment cluster, after we build security correctly, the use case should be simple and powerful. So that's my presentation. I'm going to hand over to Mike to wrap up this.
Yeah, so back to those North Stars, right? Is this thing on? Yeah. Those North Stars, we want to make it easy, but it's not, right? Analytics is difficult. There's a lot of different levers to pull. A lot of what Yiqing went through, we were talking about that on our on-premise data lake. I described that, right? That's probably the easiest, if you will, right? It only gets tougher moving to the cloud, and that absolutely is the direction we're going. But those security challenges Yiqing went through and some of the other ones, like those don't go away. They're just now up in the cloud, and there's other new concerns that kind of come up, right? So we found that just getting started was kind of one of the main objectives, right? I got enough funding together for a small 8-node cluster, non-production, and that's what we ran on for like the first 6 months or so while we figured out some of these tweaks and stuff. Then we went back and got production, and we started to form that team and show real value. Don't be afraid to fail, right? So we definitely went down some of the paths that Yiqing talked about. It's like, oh, especially in the security realm, right? Will Power BI work with this Spark driver? No, right? It won't work that way. Well, it will, but you have to suck all billion rows into it in order for it to work, right? That's not a viable solution. There was many different things that we went through, and we kind of scraped our knees as we were figuring out the best way to lay out Hadoop. Invite your quote-unquote business partners. Again, we're racing those lines, but I'm going to call them business partners into the process, right? Make them part of your team. So when we were working through that Experian data set, and they said, oh, wow, this is great. Can you, we need the performance to be less than a second. Yicheng was like, all right, let's try it. We tried it with Tez. We tried it with a whole bunch of different scenarios. And then we tried it with Elasticsearch, and they're like, oh, this is awesome. This is what we were looking for. But that iterative cycle probably took, maybe 2 weeks, maybe 3 weeks. Once we got the data there, I mean, there was some movement there. But to rapidly prototype and let them be part of it. And they get really excited, so generating some excitement about it. So last but not least, a small lake is still very beneficial, right? You can learn a lot. You can derive a lot of value out of, both for your own learning as you grow a team, but also, real business value. We use the lake, Yicheng mentioned, we use it for storage, but we also use it for a lot of machine learning models. We use it for ETL of transforming the data in that Experian example from one data set to another data set. We found it to be, extremely valuable to have the environments. So with that, that's what we have. So any questions or anything that we can answer? Yeah?
So your case one where the classic data warehousing coming into Hadoop and then have the BI. So did you guys use the Hive tables and use the Spark on Hive, or what is the interaction between your BI into the data?
Yeah, data is storing HDFS, right? So we have a Hive schema on top of it, and both Hive and the Spark engine can read the data. So we choose Spark because from performance perspective.
Yeah. Where you went the Spark SQL.
Yeah, we use Spark SQL. Depends on different kind of SQL. Sometimes Hive tags may run faster than Spark, depends on. So for example, you want to retrieve a subset of a data. You provide a key, I want to retrieve a very small subset of the data. You need to go through a table scan. The Hive tag is going to run very stable. Spark SQL, put everything into memory. If you don't do the aggregation, it could be slow. Spark is more faster when you run machine learning kind of SQL. You do the aggregation with right format, like a Parquet. Like Hive run faster with org.
Right. So did you guys benchmark between Hive and Tez and Spark?
Yeah, we
A lot.
We did a lot. Yeah.
Spark SQL is the final.
Yeah, so like a Spark with a Parquet as a buddy, and the Hive org is a perfect marriage.
Parquet now or ORC?
I'm sorry.
Parquet or org.
Parquet, right?
Spark with Parquet. Yeah.
Not ORC.
Spark is trying. Databricks were working on different Spark, different data reader. They handle Parquet faster today, so they are working on the faster reader to handle the org now.
Other questions? Yep.
How are you handling the schema changes when it comes from the source systems to the data lake?
Yeah, so the schema changes as it comes from the source systems to the data lake.
Yeah. Schema may change or may not. So in most of the case, we use Scoop to import data. So I don't need to specify what's a schema in the data lake. I just use Scoop, read the data. When data write to the Hadoop, it's generated exactly the same schema as the source system. You can also change your schema if you want, but you probably have a very good reason to why you want to use a different schema. So I think the first step is make it simple, read the data, just do exactly load data, put into Hadoop.
What I was looking at is when you try to, say if I do an version 1, I have like 10 columns, and down the lane, now the table metadata has changed. So now you're trying to import the same data because now that's going to affect all of your downstream applications. So how are you managing it? So do you have some kind of metadata layer where you're trying to capture all this metadata and try to work with those things? Or?
That's not going to be easy, right? So because you read the data, today I read 10 columns. Tomorrow I read the same table from relation database, change to 20 columns. It's not going to be fitting the same schema. You have to create a separate table.
And I think that's the question, how are we dealing with that, right? So, I mean, some of it, we're just not old enough to experience some of that, right? So, I mean, we recognize that issue is there. Actually, I see some of my Liberty colleagues in the audience here. They definitely have experienced that. Jeff's shaking his head, right, as the schema changes. And Jeff, I think you did write a meta layer on top of it, if I remember it correctly, right?
And the other thing is we're looking at Avro, right, as a standard. It's going to change a lot more. It's better. Of course, there's a lot of trade-offs when you're doing Avro.
Yeah.
It's not going to be as performant as Oracle game.
Right.
Yep.
Right.
I also had seen something about encryption of the data from the HDFS. So you're using encrypting the whole directory where you're trying to store the data. Is that what you're trying to mean there?
Yeah, HDF support encryption zone. So basically, you just type whatever key, you can encrypt the entire directory, whatever folder, whatever you name it, right? So it's client-side encryption. So when you use the user from whatever client tool, Hadoop ecosystem to access data, the data is not encrypted at rest. The data also encrypted in transit.
Okay. Are you handling any data obfuscation or PI data, or do you do any of those column encryptions or something like that?
So obfuscating and PPI data, is that what you
Yeah.
asked? So not today. Not in what we should do here, because we're not dealing with NPPI data. But, yeah. Was there another question?
Yeah, it's just analytical doesn't normally use NPPI data.
Yeah, I mean, as a company, we're trying to scrub that out as much as possible, to be honest, even in the source systems, and tokenize it. Now, where we get in trouble, well, not in trouble, but where it's a problem, right, is unstructured text fields, right, where anybody can type in anything they want, right? So, if you're a claims agent and somebody's, you decide to type in a social security number in there, that's a problem because it's not supposed to be there. So we do scans for that type of stuff. We used entity extraction to identify social security numbers and abstract them.
Yeah.
But that's done pre-processed, essentially.
Before you began speaking today, you said that you're definitely going to the cloud.
Yes.
So was that just generally speaking, or you have a specific vision, and are you looking at any specific, options
So we
for
are
doing that?
Yeah, so good question. So we're aggressively moving to the cloud. I mean, we have timelines set out by our senior leadership. We have EMR clusters in AWS that we can spin up with all the same security controls that we showed you here. When we're dealing with some of our corporate clients, so like corporate HR, corporate legal, some of these guys, the conversation goes easier when you say, hey, let's land it on our internal data lake and let's experiment. And then once we get to a solution that they like, then we talk about moving it to S3 or landing on an EMR or HD Insight. We're definitely more mature, I'd say, in the AWS space, but we're looking strongly at the Azure side as well. So
Is it that you'll use the cloud for things where there's not PII, or is there a particular strategy for what you might do in the cloud versus what you would do on-premise?
So the end goal is to have it all out there, and I think we need to be able to have an environment that is classified, if you will, up to the restricted level. Like, we need to be able to have an environment that we can handle that confidential data. So it's not so much the dichotomy of data. I mean, our cloud environments are certified from our security teams up to those levels. It's more of just a comfort. And honestly, some of the experiments that we run, they're just quicker to, if we're moving 4 terabytes from a source system to the lake, just to try something, an experiment, that's way quicker than moving 4 terabytes to the cloud. And once we know it works, then we'll figure out the pipeline to get it out to the cloud on a regular basis, right? But for experimentation, it's way faster to do it on premise there.
When you said you're looking at EMR,
Right. We're end of time. So we can talk about.
So guys,
go
thanks
there.
for joining, and we could follow up on that question right here.
Yeah.
Thanks, guys.
Thank you.
Thanks.